All right, welcome to The Explainer. Today we're going to do something really cool. We're going to build perfect shapes, but not with fancy computers or anything like that. We're talking ancient tools and a simple blueprint. So let's jump right in. So how do you draw a perfect shape? It's not magic. It really is a blueprint. Today, we're going to explore how to construct these amazing polygons using just the simplest tools imaginable. Okay, for the next few minutes, I want you to put on your architect's hat. We are going to build these shapes literally from scratch, following this incredibly precise, almost secret plan that guarantees perfection every single time. All right, first things first. Every architect needs their tools, right? But for this blueprint, you only need two, and I bet you've got them sitting in a drawer somewhere right now. And yeah, that is literally it. A straight edge, and notice, not even a ruler with markings on it, just something to draw a perfect line. And a compass. Now the compass, its real power isn't just drawing circles. It's in its amazing ability to measure and copy a distance perfectly. With just these two simple things, we can build this entire world of shapes. It's kind of wild. Okay, toolkit's ready. Let's get our hands dirty and dive into our very first construction, a basic four-sided figure, a quadrilateral. So here's our first challenge. We've got to build this quadrilateral, ABCD. Now we know the length of all four sides, and we even know the length of one of the diagonals. The real puzzle, the tricky part, isn't knowing the numbers. It's figuring out exactly where to put that final corner, point D, to make it all fit perfectly. So yeah, that's the big question, right? How do we find the exact location of that fourth corner? How do we lock it in so that every single one of those measurements is spot on? Well, the blueprint always starts with a solid foundation. First, we just draw our base side BC. Then, using that diagonal length we know, we can construct the triangle ABC. And here's the key. A triangle is rigid. Its shape is now completely locked in. This is our anchor for the rest of the shape. Okay, now for the really clever part, finding point D. Watch this. From point A, we're going to set our compass to the length of side DA. That's 3.5 centimeters, and we swing a nice big arc. Then we go over to point C, set the compass to the length of side CD, which is 5.0 centimeters, and swing another arc. You see that? That one single point where those two arcs cross? That's the whole secret. It is the one and only location that is exactly 3.5 centimeters from A and 5.0 centimeters from C at the same time. Boom, we found our point D. Okay, so that's the basic method, but now let's level up. What if we could use a shape's hidden properties, its own internal rules, to find an even more elegant, a more efficient blueprint? Let's take a look at the parallelogram. This is where it gets really, really smart. Instead of just brute forcing it with side lengths, what if we use the rules that the shape itself follows? Knowing these properties is like having a master key to unlock its construction. And this right here shows you the difference perfectly. I mean, look, on the left, that's the method we just used, building it triangle by triangle. It works, sure, but on the right, for a parallelogram, there's this much smarter, much more elegant blueprint. And get this, it doesn't rely on the sides at all. It's all about the diagonals. And here it is. This is the master key, the secret property we're going to exploit. For any parallelogram, its two diagonals always, and I mean always, cross at their exact midpoint. They slice each other perfectly in half. So check out how much simpler this blueprint is. It's amazing. You just draw the first diagonal, find its exact center. Then you draw the second diagonal right through that same center point. All that's left is to connect the dots, the endpoints, and bam! You've got a perfect parallelogram. So much easier. And because we know the rule, we can be absolutely precise. If that first diagonal is 5.6 centimeters long, we know without a doubt its midpoint is right here at 2.8 centimeters. That's the real power of the blueprint. Absolute certainty. No guesswork involved. All right, so now that we have these principles, using properties, being precise, we can apply them to create some of the most beautiful and, perfect shapes in all of geometry. So, let's take the rhombus. It's a cousin of the parallelogram, so it follows the same rule. The diagonals bisect each other. But we add just one more little rule to the blueprint. They have to cross at a perfect 90-degree right angle. That one extra constraint is all it takes to guarantee you get a perfect rhombus every time. But, okay, the construction of a regular hexagon, that's a perfect six-sided figure,
This reveals one of the most elegant, one of the most beautiful secrets in all of geometry. It's really something special.
I mean, it is almost magical how simple this is. You just draw a circle, then, and this is the key, without changing the setting on your compass at all, you pick any point on the edge and just walk the compass around the circle, marking off the points. And this is the incredible property that makes it all work. It turns out the radius of the circle fits perfectly around its own circumference exactly 6 times, which means the side length of a regular hexagon is literally equal to the radius of the circle it sits inside. It's just this beautiful, fundamental truth of how our universe is put together. So when you step back and think about it, these rules, they don't just build perfect shapes on a piece of paper. You see this logic everywhere, from the structure of a honeycomb to the design of a bridge. This fundamental logic of construction, it's more than just geometry. It's a blueprint for creation itself.